KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Free bus for LKG to 8th standard.
Free, hygienic and nutritious food.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Education Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
Good morning, students. In this session, we are going to discuss the most important theory in coordination compounds, Werner's theory. Already in my previous session, I completed Sidgwick rules and Sidgwick theory. It's nothing but EAN rule. What is the full form of EAN? Effective atomic number. So what is the effective atomic number, my dear student? After formation of the coordination compounds, how many number of electrons are present in the central metal atom? That number is commonly known as the EAN number. So what is the uses of EAN number in the coordination compound? If you determine the EAN number of the given coordination compound, what is the uses? Yeah, 100% it's more useful whenever you will calculate the EAN number. EAN numbers are decided to the stability of the coordination compound. That's why EAN number, it's a very important number whenever you will calculate the stability of the coordination compound. The entire information already discussed in my previous session. Now one more theory. This is Werner's theory. Most important theory, Werner's theory. You know that very well. In my first class, in first introduction class, I said very clearly, Werner's is the Alfred Werner's the father of the coordination compound. Who was the father of the coordination compound? Alfred Werner. So that's why in coordination compound, coordination chemistry chapter point of view, Werner's theories are very, very important. Not only NEET level, even in board level also very, very important. So every student focus clearly in this session. Okay, Nana? See, observe. Now, Werner's theory. See, the coordination compounds were known since 18th century. Actually, the coordination compounds were known since 18th century. But no satisfactory theory was available to explain the observed properties of these compounds. Okay, Nana? Actually, in 18th century, peoples also, they know very well about the coordination compound. But even one theory is also not available to explain the complete properties of coordination compound. Complete properties is nothing but either physical properties or chemical properties. Even one theory is also not available before 18th century to explain the coordination compound, physical properties and chemical properties. But Alfred Werner's in 1893, Alfred Werner's in 1893 won his Nobel Prize for concept of the coordination compound for the correct explanations about the coordination compound. So in 1893, the great scientist Alfred Werner, he won Nobel Prize to explanation of the physical and chemical properties of the coordination compound, also shape of the coordination compound. He could explain very clearly about the coordination compound, physical properties and chemical property. Hence, he got Nobel Prizes in 1893. So now, how to explain the coordination compound theory and physical properties and chemical properties, the complete information we are going to discuss in this Werner's theory. Okay, Nana? Now see here, the most important point is Who was the father of the coordination compound? Werner is the father of the coordination compound. Alfred Werner is the father of the coordination compound. Now see here, important point, the postulations of the Werner's theory. What are the important key points or postulations in the theory of the Werner's? So see Nana, one by one point clearly. The first point is Mr. Werner using simple experiment techniques, he could tell structure and physical and chemical properties of the coordination compound. Most important, Nana, he was using the very simple experimental technique. He could tell the structures and physical and chemical properties of the coordination compound. And according to Werner's theory, the Werner's theory says that there are two types of valency are present in the coordination compound. So based on the Werner's theory, every coordination compound contains two valencies. The first one is the primary valency, second one is the secondary valency. Primary valencies and secondary valencies. So this is the most important, Nana. According to Werner's theory of coordination compound, every coordination compound contains two different type of the valencies. The first valency is the 1 degree valency, is nothing but primary valency, and the second one is the 2 degree valency, is nothing but secondary valency. Now see Nana here, what are the major differentiations between primary valency and secondary valency? How to identify which species belongings to primary valency and which species belongings to secondary valency in coordination compound. Now we are going to discuss the differentiations between primary and secondary valency. Primary and secondary valency. Now see here, first one, in the primary valency point of view, my dear students, primary valency point of view, anions show primary valency. Most important, in coordination compound, the anions show the primary valency. And the secondary valency point of view, anion and neutral species show the secondary valencies. One more important point, the primary valency are those which a metal normally exhibited in the formation of the simple salt. So in a primary valency are those which a metal normally exhibited the formation of its simple salts. Okay na? And the second point is these are ionizable. Most important point, Nana, write down in your class notes. Which are the ionizable according to Werner's theory? Primary valencies are ionizable. Ionizable means it can easily to split into the ion in the aqueous solution. So that's why my question right now, which valencies can easily to ionizable according to the Werner's theory from coordination compound? Primary valencies are easily to ionizable. It splits into ions. And secondary valency. Now see Nana, secondary valency, they are non-ionizable. It means they cannot split. Which one is not split in from the coordination compound? Which is the secondary valency? Which are the secondary valency? They cannot non-ionizable. They can't split actually. So whenever in aqueous solutions are soluble, they can't ionizable. But the primary valencies are easily to ionizable to splits into the two ions. And third important point is non-directional in the nature. Most important point, Nana. According to Werner's theory, which valencies, primary or secondary, non-directional in the valency, non-directional in the nature. That's why primary valency could not tell about the structure of coordination compound. What is the reason? Here the primary valency non-directional in the nature. That's why they could tell any kind of the shape and structure of the coordination compound. But in the secondary valency, see Nana, they are directional in the nature. The secondary valency only to could tell about the structure of the coordination compound. That's the most important, Nana. Primary valency, it's ionizable but non-directional in the nature. And secondary valency, non-ionizable but they are directional in the nature. Secondary valency only to decide the shape and the structure of the coordination compounds. Now see here, fourth point about primary valencies. They are represented in dot lines. Underline this point. Whenever primary valencies are present in the coordination compound, it's represented with dot lines. This is like that, dot lines. And in secondary valency point of view, they are represented with thick lines or dark thick lines. So primary valency, whenever you will draw the coordination compound based on the Werner's theory, இப்போ primary valency இருக்கனா compulsory you will draw the dot lines, but secondary valency இருக்கனா thick lines. These are the most important two important points. Once again repeated in the fourth points. Primary valency you observed in the anions, and secondary valency is also observed in the anions and neutral species, and they are ionizable, they are non-ionizable and non-directional in the nature. That's why it's not decided to the structure of the coordination compound and shape of the coordination compound. So what kind of the shapes are there? You know that very well. Trigonal planar, tetrahedral, square planar, trigonal, bipyramidal planar, octahedral planar. This all kind of the structures only decided by the secondary valency, not for primary valencies. So they are represented in dot line. Primary valency is always represented in the dot lines, and secondary valency is always represented into the dark thick lines. Okay, Nana? Now see fifth point about primary valency. In a modern concept, actually see Nana, in a olden concept is nothing but according to the Werner's theory. In the Werner's theory, primary valency is anion and ionizable, non-directional. But in the new concept or modern concept point of view, 1 degree valency is also updated as an oxidation number. In coordination compound, according to the modern concept point of view, primary valency is considered as a oxidation number. That's the most important point. In the modern concept, in a coordination compound which is act as oxidation number, 1 degree valency is considered as a oxidation number according to modern concept. Aprama 2 degree valency from the Werner's theory, 2 degree valency in modern concept point of view, coordination number. That is the most important point, Nana. According to the Werner's theory, 1 degree valency is nothing but oxidation number in modern concept, and 2 degree valency is coordination number in the modern concept. And these are the basic 5 important differentiations regarding to the primary valencies and secondary valencies. And sixth important point, see here, sixth most important point, there are some species it can act as a both valencies. It's called dual nature. It's called dual nature. For example, my dear students, some species act as a both primary valencies and secondary valency. So such kind of the species is represented by both lines. Number one dotted lines along with the thick lines. So this kind of the symbol, this kind of dot lines are present in any coordination compound. It's represented both primary valency and secondary valency. Primary valency and secondary valency. So the most important point, according to Werner's, all secondary valency has shapes, arrangement according to the coordination number. So according to the coordination number, secondary valency only to show the shapes and structure of the coordination compound. Okay, Nana? These are the basic important differentiations of the primary and secondary valency. Now, Mr. Werner to explain some examples with shapes and structures. Explain some example with shapes and structure. The first compound is CONH3,6Cl3. This is the first compound. According to Werner's concept, see Nana, 1 mole of Werner formula. 1 mole of Werner formula means CO6NH3Cl3. This is 1 mole of hexaamine cobalt chloride. Hexaamine cobalt 3 chloride. Actually, this is the first example. According to Werner's formula, CO6NH3Cl3. It means this entire the coordination compound is represented 1 mole. That's why CO6NH3Cl3. Appo enna color irukidi? Yellow color. But the modern formula, this is Werner formula, but modern formula enna the compound? CONH3 6 takens Cl3 da. From this compound, which is the primary valency and which is the secondary valency, which is the both one. So carefully see, Nana. Here primary valency, Cl3 is a primary valency. Why say any one of the students? Why Cl3 is act as a primary valency? According to the modern concept, ionic sphere is act as a primary valency. Why Cl3 is act as a primary valency? Because this Cl3, it can easily to ionizable. Which species can easily to ionizable in the aqueous solution? That is a primary valency. That's why here primary valency number is 3 because Cl3 is easily to ionizable. Aprama secondary valency from this compound, which is a secondary valency? Ligand, coordination number. This is a coordination number, ligand. How many ligands are there? 6 ligands are there. These 6 ligands are represented as a secondary valency because it's a non-ionizable species and non-ionizable species. That's why it's act as a secondary valency. So in this given example, see primary valencies are 3 because outside of the square bracket, and secondary valencies are 6 inside of the square bracket, such as ligands. Okay, but in this species, in this compound, there is no any species count to show dual behavior. So 3 chlorines are primary valencies and 6 ammonias are secondary valence, but cobalt is a central metal atom. But Mr. Werner's decided CONH3 compound the same like this formula. How he was decided? Cobalt ammonia chloride formula CONH3 So he did one extraordinary experiment. This compound, entire this compound treated with silver nitrate. Treated with silver nitrate na AgNO3. Appo NiH silver nitrate directly reacted with chlorine, 3 moles of the chlorine, hence 3 AgCl is formed. That's why he was decided outside of the square bracket 3 chlorines are there. How he was decided outside of the square bracket? According to the formula point of view, CONH3 outside 3 chlorines, how is it possible? Because he did one experiment, silver nitrate solution added to this compound, immediately 3 moles of AgCl formed as a precipitate. So this information is clearly to explain to the concept, explain to the concept what happened here. Cl3 means 3 AgNO3 treated with the Cl3 to form AgCl. That's why he is decided and he concluded outside of the square bracket 3 chlorine atoms are there because of the 3 AgNO3 treated with 3 chlorine, hence to form the precipitate of the 3 AgCl. So this is the modern formula, this is the Werner's formula. What is the color of this compound? Yellow. Here primary valencies are 3 because of outside ionizable product, and secondary valencies are the 6. There is no any dual nature species. Next example, 1 mole of Werner's formula, CO5NH3Cl3. This is the Werner's formula, but in modern formula point of view, CO as usual central metal atom, NH3 taken 5 times, 5 NH3, அப்புறமா ஒரு Cl inside இருக்கு, outside 2 Cls are there. How he decided outside 2 Cl is there? Because of AgNO3 treated with this chlorine, 2 moles of the AgCl is liberated. That's why he concluded outside of the square bracket 2 chlorine atoms are there because based on the 2 AgCl precipitate molecule. 2 AgCl precipitate molecule. Now see here in this example, my dear student, 3 are the primary, 6 are the secondary valence. 3 are the primary means here outside 2 primary, and even this chlorine is also act as a, but it's present in inside of the square bracket, but these 2 chlorines along with this chlorine act as a primary valency. That's why here 3 chlorine atoms act as a primary valency. But in formula point of view, AgNO3 treated with only 2 moles of the chlorine. That's why here AgCl is 2 AgCl molecules are there. That is the reason in outside of the square bracket only 2 chlorine. But ultimately this 2 chlorine along with this chlorine is act as a primary valency. Aprama 2 degree valency. 2 degree valency means these 5 ammonia groups along with this chlorine. It means the inside of the single chlorine atom act as a primary valency as well as secondary valency. That's why here dual behavior species this chlorine. So the most important here primary valence 3. It means the inside of the chlorine, in square bracket inside of the chlorine act as a primary valency is also secondary valency. Primary valency and also secondary valency. So in the primary valency point of view 3, also secondary valency point of view also 3 the secondary valence point of view 6 the, but dual means this chlorine act as a both primary valency also secondary valency, that's why in the dual point of view 1. But here how many AgCl precipitates are formed? 2 the, so these are the purple color compound, okay nana. So how he was decided the formula of this one Cl2 is outside, because AgNO3 treated with chlorine to form 2 AgCl, so he concluded outside of the square bracket only 2 chlorine atoms are there, but this 2 chlorine atoms including inside of the chlorine atom also act as a 1 degree valency, and this amine 5 amines also this chlorine act as a secondary valency. Now see nano, third example CO4NH3Cl3. It is a green color compound and it is a Werner formula, but in modern point of view see CONH3 taken 4 times Cl2Cl. Now see here also see carefully primary valency this one and including this 2 one, so the primary valency is the 3 because of outside 1 chlorine inside 2 chlorine, both of them is the primary valency, and 2 degree valency this 2 and along with 4, so total 6, there is no any difference. So here but outside of the chlorine only 1 chlorine is there, because of the AgNO3 treated with 1 chlorine to exhibited AgCl, that's why outside of the square bracket only 1 chlorine is there, but inside of the square bracket 2 chlorine is there, but the total chlorine inside of the 2 chlorine act as a primary and also secondary. So secondary means this 4 plus 2 total 6 the aprama outside 1 primary valency, inside this 2 one act as a both dual, that's why here dual point of view 2. Why 2? This Cl2 2 are can be existed as a both character 1 degree valency and also 2 degree valency. Clear ma? These are the most important. And last and final compound, same formula, there is no any different, CO4NH3Cl3, but same modern formula also same, and primary valency also same, secondary valency is also same, and dual behavior also same, but formation of precipitate is also same, but color is changes. Why? Here third example is same molecular formula, color is different, because of this both compound can exist at geometrical isomerism, cis and trans, that is the basic reason. So the same molecular formula but they can exist a different type of the structure, cis and trans, that's why this compound is show different type of the color, but the primary valency and secondary valency are same, even dual species also same. These are the Werner's theory important postulation. Now one examples along with structure nana, CONH3 taken 4 times and Cl2Cl. See here the same example nana, same example, this chlorine and inside of the chlorine both of them is act as a 1 degree primary valency and also secondary valence. Secondary valence means the Cl2 act as a primary valency, secondary valency. Ammonia act as a only 2 degree valency. Chlorine is act as a only 1 degree valency. So based on this information, how he was draw the structure of this compound, Werner's. See nana, which is the central metal atom? Central metal atom is always present in the inside of the molecule, cobalt. Aprama, how many ligands are there? 4 ligands are there. In the 4 ligands, NH3, 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 NH3. So nitrogen only donated to the lone pair of electron to the central metal atom. That's why I put here N, bond with cobalt, bond with nitrogen, not hydrogen. Because of nitrogen only to donated the lone pair of electron to the central metal atom of the cobalt. So after that, here 2 dot lines are there. Chlorine, 2 dot line. Because of these 2 chlorines act as a both behavior. Already I represent clearly, if any one of the species can be act as a both primary also secondary, it's represented both dotted lines and thick lines. So now here this chlorine and this chlorine, here Cl2 irukna, this chlorine and this chlorine both of them is act as a both behavior like 1 degree valence and 2 degree valency. But outside of the chlorine this only single, only dotted lines, because of its act as a only primary valency. And in this example this chlorine is a primary valency NH3, 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 NH3. This 4 NH3 along with the chlorine, this 2 chlorine act as a 2 degree valencies, and it's nothing but secondary valency. Aprama, which is the dual? This 2 chlorine act as a dual. Okay, Nana? These are the Werner's theory postulation. So, according to Werner's theory postulation, he could tell very clearly to be explained the physical and chemical properties of the coordination compound and also structure of the coordination compound based on the primary valencies and secondary valencies. Okay, Nana? Now, limitations of Werner's theory, but I am not mentioned here, just listen every student. Limitations of the Werner's theory. Werner's was the first to explain the bonding feature in a complex compound. However, this theory could not explain the following queries. So, what kind of queries is not explained? First one, why the complex forming tendency is limited to a few elements only? And second one, why do bonds in the coordination complexes are of directional in the nature? And third one, why do certain complexes are magnetic nature and show geometrical and optical isomerism? This theory at present has lost of the relevance and has been replaced by the more exhaustive theories. So, this kind of the limitation you can't explain Werner's theory. In after further theories, after Werner's theory, the new theories also came. The theories are clearly to be explained about coordination compound structures and coordination compound physical and chemical properties. Such kind of the theories is called valency bond theory, VBT theory. Simply it's called VBT theory and CFT theory. CFT theory means crystal field theory. So, remaining two theory I will be explained in my next session. Okay, Nana? So, this is the most important part in coordination compounds.